Whoa! Welcome to lesson 6.4, squares and rectangles. Today we will be getting into all the nitty-gritty that you need to know about squares and rectangles to love them in the deep way that I do as well. So, before we talk about squares and rectangles, let's talk about parallelograms, because guess what? Squares and rectangles are actually just parallelograms, just special cases of them. So we probably have to remember really what makes a parallelogram, or what is its properties. And it has 5, and the first one is opposite sides are parallel. All right, opposite sides are parallel. That's really what makes it a parallelogram. And if this is true, if you know opposite sides are parallel, then you know it's a parallelogram. Another way you can know something's a parallelogram is if opposite sides are congruent. All right, if the opposite sides are congruent, well, then it's a parallelogram. Opposite sides are congruent. So for example, if I knew that this was 5, this was 5, this was 6, this was 6, well, since opposite sides are congruent, then I know this figure is a parallelogram. More, opposite angles are congruent. So the angles are across from each other. So like this would be congruent to this, and this angle would be congruent to this angle. So if you knew opposite angles were congruent, you knew it's a parallelogram. Keep going. Adjacent adjacent angles are supplementary. We'll just put 180 here. That's another property of parallelograms. And finally, last but not least, diagonals bisect each other. Bisect each other. So what does that mean for the rest of these special parallelograms? Well, the 3 special parallelograms that we're going to be talking about are rhombuses, which we did in the last lesson, rectangles, and squares. And since all 3 of these are parallelograms, they share all the properties of parallelograms. All right? So a rhombus, all of these are true for. A rectangle, all of these are true for. And a square, all of these are true for. But what makes them special is that they have their own other special properties. It's like they're the kids of parallelograms, but then they got some of their traits from their fathers, or something like that. Anyway, a rectangle has 2 special traits that really make it special. The first one, and this you might remember, is that all angles are 90 degrees. All right? So in a rectangle, it's a parallelogram, so it has all the properties of a parallelogram, but it also has to have 90-degree angles for all its corners. Got it? So that's the number 1 thing that makes a rectangle a rectangle. Now the number 2 thing, and this is what makes it special from regular parallelograms, is diagonals are congruent. So we know that diagonals bisect each other in parallelograms, but what is only true for rectangles, and not just any parallelogram, is that your diagonals are congruent. So I'd say this whole thing, where's my pen? Where's my pen? Where's my pen? There it is. This whole side, if this diagonal is 10, then my other diagonal has to be 10. The whole thing, this whole diagonal is congruent to this whole diagonal. And that's really what makes it special, these 2 facts. So it has all the facts of a parallelogram, plus these 2 additional ones. So all angles are 90 degrees and diagonals are congruent. So if these 2 are true, all right, if you know that all the angles are 90 and the diagonals are congruent, then you know it's a rectangle. Quadrilateral ABCD is a rectangle. All right, now let's use some of the properties we just learned to solve this problem. We know AB is 16, AC is 12, and AD is 10. Find the measure of the following segments. Well, easy enough. Let's just start by filling in the information we know. We know AB is 16. We know AC is 12. So this whole diagonal right here, that's 12. And we know AD, this side right here, is 10. All right? First thing we want to know is the side length of CD and BC. So CD is right here and BC is right here. Well, just looking at this, I know the opposite sides are congruent, so I could just fill these in, right? Don't they even look congruent? These opposite sides look about the same length. So I know that CD is going to be equal to 16, and I know BC is going to be equal to 10. Did I just fill in the wrong order? I did. 10 and 16. Okay. The property we use to this is the property that we know about all parallelograms. Okay? Opposite sides are congruent. That's the property that helped us solve this, right? We know that opposite sides are congruent, so that helped us solve this problem. Now the second one, we want to know what BD is. What is the length of BD? And that's right over here. And this is the other diagonal. Now remember, we knew that in rectangles, the diagonals are congruent. So we know diagonals are congruent. Well, how does that help us? Well, if we know one of the diagonals is 12, then we know that the other diagonal, or BD, is also 12. So BD is going to be 12. And we did it, like G's. All right, next problem. In rectangle ABCD, AC equals 3x plus 15 and BD equals 4x minus 5. Find the length of AC and state the property used to solve the problem. All right, I think we can handle that one. So let's go for it. First thing, since we don't have a picture, remember, a good first step always, if they're not giving you a picture, is to draw it. All right? So let's draw ourselves a rectangle. You guys can use a protractor. I'm going to use this easy electronic version of a rectangle that I have. So we're drawing it, and we're going to label all our sides. So we know it's A, B, C, D, and we know AC, which because it's not a direct side length, we know that's a diagonal. We know this diagonal right here is equal to 3x plus 15. Now, the second part we know is BD, which looks like to be another diagonal. So let's fill that in. All right, here's our other diagonal. And that is equal to 4x minus 5. So how does that information help us solve this problem? Well, what do we know about the diagonals of rectangles? We know the diagonals are congruent. All right, since we know what the diagonals are, 3x plus 15 and 4x minus 5, we know they have to be congruent. So another way to say that would be that AC must be congruent to BD. These diagonals are congruent. Now from here we can set up our equation by just substitute the values in. So when things are congruent, we could just set them equal. So AC is equal to 3x plus 15. And we know BD is 4x minus 5. All right, well now we just want to find the value of x that makes these two congruent. So we're going to put a line down, and let's just start solving it out. First thing we're going to do is subtract 3x from both sides. Okay, that cancels. We get 15 equals x minus 5. We'll add 5 to both sides, and sure enough, we get x equals 20. Now, I'm not sure I believe that that's the answer, so let's see if when we plug in 20, we get the same answer, the same length for both AC and BD. So if I want to find the length of AC, I'm going to do 3 times 20 plus 15. If you put that in the calculator, you'll see that that is equal to 75. Okay, so the length of AC is 75. Now to find the length of BD, well, let's see. That is 4 times 20 minus 5. And when we put that in the calculator, 4 times 20 is 80 minus 5, that is 75. 80 minus 5 is 75. Are they the same length? Yes, so that value of x makes these two congruent. Sweetness. And finally, in rectangle ABCD, AB is equal to 12, okay? And BC is equal to 9. Find the length of AC and state the property used to solve the problem. So AC is right here, and we want to find the length of this, and we only know the side lengths. What property can help us solve this? And that's an interesting question. Now if you look, if we take AB, and we take BC, and we take AC, it looks like we have a triangle right here. Furthermore, we know that this is a right triangle because all the angles in a rectangle are 90 degrees. Now this is getting interesting, right? Because if I have a right triangle and I know two of the sides, didn't we learn how to find the third missing side? We sure did. We used the Pythagorean theorem. So the property that helped us solve this problem was knowing that all angles are 90 degrees, right? So now we just have to plug in. Well, we know that the two legs are 9 and 12, and the hypotenuse, which is across the 90-degree angle, is AC. So we would just say that 9 squared plus 12 squared is equal to C squared. 81 plus 144 is equal to C squared. 225 is equal to C squared, and we take the square root of both sides, and we get C is equal to 15. All right? So our missing side length, or the length of AC, AC is equal to 15. Right? So remember, when you want to solve problems with parallelograms or any other problems, the first thing to do is to find out what information would help you solve it, right? And that's the properties. So think about which property is going to help you solve any problem, okay? Moving on, what is a square, okay? A square is another one of our special parallelograms. And what's special about a square is that it's like if a rectangle and a rhombus got together and made a baby. And what do I mean by that? Well, a square has all the same properties of a rhombus, okay? It shares all the properties of a rhombus, meaning all sides are congruent, remember? So that has all sides are congruent. So it is a rhombus, all sides are congruent, and that means all the other facts about a rhombus are true, that, what's it called? The diagonals bisect the angles. You might remember that for rhombuses, we know that the diagonals bisect the angles. So if I had a diagonal here, okay, it bisects the angles in two, right? 3, the diagonals are perpendicular. So once again, these are just the rhombus properties, all right? If you have a square, the diagonals intersect to make 90-degree angles, so they also share all the same properties of rhombuses. So here's all your rhombus properties, okay? So it's a rhombus. Furthermore, it has all the same rectangle properties, all right? So what's that mean? Well, the diagonals are congruent. All right? So we know those two diagonals are congruent, and we know all angles are 90. So just like a rectangle, it has those properties. So in all squares, all the angles are 90 degrees, the diagonals are congruent, and all the sides are equal. So these are what it takes from a square, all right? These are a rectangle properties. Let's see if I can write side. Nope, I can't. I'm not smart enough to do that. Let's put that in rectangle. All right, these are those rectangle properties. And furthermore, it's a parallelogram, so it shares all the same parallelogram properties. And I should have had one more spot there, but this is where we put the parallelogram properties, which we should be used to by now. And let's put a 9 down here, because we're missing some room for that. Now here's a little fun fact about squares. All squares are both rhombuses, all right? They're rhombuses because every square has 4 equal sides, so it must be a rhombus, and all squares are rectangles because all angles are 90. They're both squares and rectangles. I mean, squares are both rhombuses and rectangles. Every square is a rhombus and every square is a rectangle because they share all those properties. So once again, we're going to go through the same process. What property is going to help us solve these problems? Quadrilateral ABCD is a square. AB is equal to 12 and AD is equal to 8x minus 4. Find the value of x and state the property that helped you solve it. Well, what do we know about these sides? Since we know the side lengths, what do we know about the sides? We know all sides of a square are congruent. Since all the sides are congruent, we could just say that AB is congruent to AD, all right, as we marked here. We can then set up our equation. AB is equal to 12, and AD is equal to 8x minus 4. We'll solve by adding 4 to both sides. We get 16 is equal to 8x. Divide both sides by 8, and we get x is equal to 2. All right. Well, let's just check if you don't believe me. Since AD is equal to 8x minus 4, let's try plugging in 2. AD is equal to 8 times 2 minus 4. AD is equal to, let's see, 8 times 2 is 16, minus 4 is 12. Sure enough, if x equals 2, then all my sides are congruent. So x is equal to 2. And finally, we have 2 more problems. Quadrilateral ABCD is a square. Find the missing angles and state the properties used to solve these measures. All right? Well, let's start with this. We want to find out what ADC is. Now, first of all, I want to say I'm sorry for this lesson going on long. All the lessons in this chapter have been a longer. I promise you in the next chapter I might make them a little shorter. But just stay with me. This is important to know. So the first thing we want to know is find the angle ADC. So let's highlight that. That might help us out a little bit. Grab your highlighter. So we want to find ADC. And that's this whole angle over here. Well, what do we know about the angles of a square? They are all right angles, right? So each angle is 90, so that means this angle, ADC, must also be 90 degrees. And the property is that all angles are 90 degrees. Okay, now I'm going to get rid of this jazz for a second. My next thing that I want to find is angle ADB. ADB. Well, that's an interesting one, right? And the way we're going to solve that is this. First, you have to remember that ADC is 90-degree angle. We just figured that out, right? We also know that the diagonals bisect the angles, right? And what's bisect mean again? It cuts it in half. So BD bisects ADC, meaning that if it cuts in half, it cuts a 90-degree angle in half, both of these are going to be 45 degrees because the diagonal cut it in half. So ADB is just 45 degrees, all right? And it'll always be that in every square, right? Because this is always cut in half. So we know that diagonals bisect the angles. 3, AED. What is the angle AED? And let's erase this. All right. AED. That's right here. AED. The angle is right here in the center. And what do we know that about the diagonals in a rhombus or a square? They're perpendicular. So this angle AED also must be 90 degrees. And how do we know that? Diagonals are perpendicular. All right, final problem. All right, the diagonal square XWYZ is 10 inches long. Express the length of side XW as a radical and a decimal. Well, follow along with me because it's about to get real complicated up in here. Well, we know XY is 10 because that's one of the diagonals. We also know that the other diagonal is also 10, right? So we have 2 diagonals that are 10. You with me? Okay, keep following along. Second of all, I know that all the angles are 90 degrees. So we know that this angle is a 90 degree. And what I'm trying to do right now is just make myself a triangle, a right triangle. Because what can I do with right triangles? That's right, I know how to find the sides if I know 2 of them. The thing is, I know that both the whole diagonals are 10. But remember, in a parallelogram, diagonals bisect each other. So that means it cuts in half. So if this is, the whole thing is 10, I know that it just is cut in half into 2 sides of 5. This is 5, right? Because it just cut in half. 5 and 5. And this is also 5, and this is 5. Well, now I have a right triangle, and I know 2 of the sides, and I just want to find the last side. So to do that, I just have to set up sorry, the properties, there's just a lot of them. To do that, I'm just going to have to set up my equation, and that's a squared plus b squared is equal to c squared. In this case, I know that my two sides are 5. That gives me 25 plus 25 is equal to c squared, and 50 is equal to c squared. So c is equal to the square root of 50. I don't have a calculator to find decimal, plus I feel like this video is way too long already. So, hopefully you have now understood the main point that I want to tell. You must use the properties to help you solve these problems, and it's important to know which property you're using to solve it. Alright guys, thanks for paying attention for so long. I'll try to keep them shorter, and you should never... Don't forget that. It's the most important thing I'll ever tell you.